Okay, so I didn't get any requests for topics today. So the things on my list are partials and multi-methods, which are both kind of functional concepts that we can look at. Maybe, I think Scott's familiar with them. I don't know if Easton or Shiza, if you've ever encountered these before, or if you know you've encountered them before. So we'll look at them here. For starters, does anybody have an explanation of what they are, or have questions? Easton, have you heard of these?
Yeah, I know what a partial is. What was the other one? Multifunction?
Multi-method.
Multi-method. So no, I don't know what the second one is.
Okay.
But I know how partials work.
Okay, tell us a little bit about partials.
It's like creating a incomplete function. So if you want to, like, I basically think of it like preloading parameters, or let's see, because you can, if you type partial and then you put in a method, and then one of its parameters to that method, it basically just fills it in and then creates a new function that only needs one more parameter per se.
Oh, exactly right. Yeah, you're even talking about Clojure partials.
Yeah,
so that's perfect. Right on. All right, Shiza, have you ever encountered these before?
Yeah, I know what a partial is. Like Easton, but I don't know multi-methods. I think I've used partial. I've read about it from the Clojure partial. It's like a pre-filled argument of a function.
Yeah, that's pretty much correct. Especially, I mean, practically, that's totally correct. So, in functional programming, so the concept of partials is abundant, and it's also present in math.
Yep.
In our code, it works the way you said. It's related to the concept. Maybe you've heard of currying, which is largely a functional concept. It's in math as well as functional programming. And partials under the hood are not exactly the same, but they work similarly for our needs to currying. So if you read any of the textbooks about functional programming, a lot of the time they bring up the subject of currying as one of the hallmarks of functional programming. And so partials are kind of like that. Although if any functional programmers end up watching this, then they're probably going to get after me about that, saying that. But the idea with currying is that you are programmatically generating smaller arities of a function, which is basically the same thing as far as our usage is concerned. So let me share screen here, and we'll get started briefly with partials. But I think most of you are pretty familiar already, so we'll go ahead and make that brief. And I will share. All right, so what we're talking about today really takes us to the DB sections of our program. So in this case, I'm in our main program, but I think all of our patterns follow this. So the idea here is that we have a DB section, and it has a core namespace that has things that the other namespaces all refer to. And in particular, we have our Crud functions. Let me find that. All right. So we have our core Crud functions: create, read, update, and delete, and all of them are pretty general. So they do not say what table that you're going to be doing those functions to. That's an argument you pass in, and they expect to receive a Clojure data structure, which will be converted to the SQL code using the Honey SQL library, which is pretty nice. So again, this means that we get to usually avoid writing SQL, and we can just stick with Clojure. So we have create, read, and there are a couple of things. Read is actually a multi-method. We'll talk about that in a second. Update, and we implement soft deletes, and so we have one thing which is the hard delete or the permanent delete, which is literally taking it out of the database table, whereas the soft delete means putting a deleted keyword on the item, and is implemented by mark deleted. Okay. All right, and then we have a couple other things also, like clone to copy a structure to an identical with a different ID. So, all right. So we have these core functions, and then we head to one of our any of our other tables in here. So usually we set up in this project a namespace for every table in the database. And so if we head to one of these, like let's choose schools, you can see that we have a lot of partials. So this is exactly what Easton said earlier. These partials are just pre-filling it with one of the args. In this case, the table. So this makes for a very handy pattern, because whenever you're writing something that needs to utilize CRUD on this table, you automatically know the names of the functions that will do that. So we've got the partials there. Now, what we didn't mention earlier, but partial can have any number of arguments. So as long as it's got not more arguments than the base function takes, you're okay. So if the base function takes, if it's a sloppy linear program that takes 5 arguments, then you can put 4 of those arguments in a partial. So if that's the way that it's been written. Hopefully, we all know better than to write that way these days. It's much better to use a map in that case. We use the rule of thumb to use a map whenever you're going over 3 args, and at 3 args, you're kind of on the fence between whether you should do a map or you should do sequential arguments. It's kind of, usually you'll do a map in that case, but sometimes, especially if you're just barely growing to a larger array and you don't expect it to grow much more, then maybe sequential is okay in that case. But with interop, so if you're using somebody else's library, you don't have a choice, but you can partial it. So you can use partials to easily get around there. So every one of these namespaces has partials like this, and the key feature here is that these are not defins; these are def. These are def with a function as the variable. So it's essentially the same as a defin. It's doing the same thing at the end of the day. What would happen if we used a defin instead of a def here? Any ideas? On any of these partials, if we were to use a defin instead of a def, it would behave differently, because in that case, something like read would then be a function which returns a function which returns a function. So right now, we say read is just a def, and then the thing that's bound to it is the result of the partial function. And the result of the partial function is always another function, which wraps the earlier one with the preset arg. If we use defin, then the calling of partial would be what the defin does. So read would be a function which returns a function that calls partial. So in other programming paradigms, there are things like the factory models where you create creators. And that would be basically what would happen if you're using a def in here. But in Clojure and in functional programming in general, usually you don't need to do that. So def is the answer. All right. Any questions about partials?
I was gonna say, if you fill the same, if your base function takes 5 arguments and you put 5 arguments in after it, does it throw an error?
No, it just is kind of useless, but it's
Right.
Well, okay, actually no, I take it back. It's not useless. Maybe it's handy to be able to just not think about the args. If you gave it 6 args, but the base function only takes 5, now you've got an error. But as long as you're within the number of functions, whether or not it's handy or not is a different question, but it would be okay. Good question. Any other questions? All right. So that is our partials, and now we'll go back and look at def methods. All right then. So multi-methods are a way of doing, man, I should have been working out my vocabulary in my mind before this. Okay, so Dispatch, that's the word. So multi-method methods are a way of implementing dispatch so that you can have different functionality based on something about the args you're given. So you're familiar with any programming language has dispatch based, well, almost any, has dispatch based on the number of args. So if you've done Java, for instance, you know, I can make a function and I can say, if you take 1 arg, do blah, blah, blah. If you take 2 args, you do something different. And 3 args to be different again, and so on. But that's not quite... So multi-methods are a lot more flexible than that. So you can do that easily in Clojure. You just write your defin, and you actually... Maybe you haven't done this, but in defin, you can actually specify... like this. So it is very easy to do parameter dispatch this way in Clojure. So if you want your function to simply do different things based on the number of args, it's very easy to implement it this way. So that is not necessary with multi-methods, though. So a multi-method, you can say based on something else. In other words, I say based on a function I give it, it will do things differently based on the result of that function. So in this case, you start with the syntax def multi. So here we have def multi read, and I have a string, and then I have the function. So the def multi is kind of the parent function. And in this case, all it has here is the dispatch function. So it's going to have a function here, and it clarifies what args are necessary, and then it has inside details about what it's going to do to those args to determine where this function goes. So this function does nothing but decide how to pass the call onto another function. In this case, we have a conditional. So we say if you know the sumFn function is checking if any of these functions return true. So if it's a UUID, or if it's nil, or if it's a string, whichever the v thing that was passed in. So if that's one of those things, then we're going to call it sequential. And by the way, so to keep in mind here what we're up to.
Mm-hmm.
All right, so you can see the function here. We've got a first param, and the multi-method is using underscore here because this multi-method does not care what that param is. Now, the actual methods we define later, they do care, but this one does not because it's not part of the dispatch. So we have to make a slot for it, but we're not going to use it here. What we are using is any number of other inputs are okay. So it's acceptable to have, we don't know how many inputs there might be, but we care about the first one, which is going to be v. If v, sumFn, is UUID, nil, or string, then we're going to dispatch with something, just a keyword sequential. And we'll see in a second what that's going to do. Because right now, you don't have to think any magic here. It's just remember, we're going to call it sequential if it's one of those three. If it's a map, we're going to call it map. And if it's anything else, we don't really know what to do with it, so we're going to throw an error. And by the way, this is one more handy thing in Clojure. Xinfo, this is Clojure core again, so nothing included here. Xinfo generates an exception with Clojure data. So you've got the string that it's going to be displaying, and then it's got a map usually that says, whatever you want. So in this case, well, maybe it's handy when the error message pops up to say what was actually given. So we're going to have that here. So, okay. So we've got our multi-method, and it's got a function that is going to name the stuff that comes in, either sequential or map. Okay. Now, the next thing you have to make it effective are def methods. So it's easy to think multi-method. Multi is the first thing, and the method is the next things. Def method, in this case, it's got the same name, and then it has what is the thing it matches. So this time says if it's sequential, and you can remember up above where we said if it's one of those three things, we're going to call it sequential. If it's sequential, then do this function. And now above, this was underscore because we didn't care. Now we care. Same args. So remember that when you call these things, it's one call going through this whole train of, well, I should say train, this pair here of the parent and now the child method. So which table is it? And then any number of extras and ID, that's the one we actually dispatch based on. So up above, we called it V because that's where we set a sequential or a map or whatever. Here, we just call it ID. And then we have something called select field keys, which was not part of the dispatch. So it could be here. It's optional because of this ampersand. But select field keys could be here. And we'll deal with it when we get there. Okay, so here we are in the sequential. Now, in mind, what this means is that you've given me an ID number. One specific number probably in a list or something. Okay. Okay, so we've got ID, and we're using a useful construct here. Have any of you utilized cond thread?
I have.
All right. Shiza, did you say you have or not?
I've used con the function before.
I used cond a number of times before I found out about con thread. And when I found out about con thread, I was just thrilled. It was awesome. Scott, can you tell us a little bit about how this works?
Sure. So con thread has the first argument that gets passed into the next expression, which in this case is the ID. And for every expression, if it evaluates to be true, then the result is then passed into the next portion, and then it combines everything. So it basically creates a new map where with the ASOC and the where keyword. So now you have a new map, and then it goes on to the next function. It evaluates if that's true, and if so, then it continues to merge in the result from the previous into the next, and it kind of goes through that whole process. It takes your initial object, compares it with a whole bunch of different conditions. If the condition passes, it calls a function upon the original object and then passes that on to the next condition that it's going to compare it against.
And the beauty of it is, what if it doesn't pass?
Then it just skips over it.
But it keeps going, right?
Yes, that's right.
And that's what blew me away when I discovered this was, whoa, that is so useful because it's letting me do conditionals in a really simple way here. I can check if something is true, but I don't break if it's not true. I just keep doing other stuff. So it's for data manipulation, so handy.
Mm-hmm. So like one instance of where I've used it is I've done some cryptography labs where you have to basically manipulate bits in a finite field with multiplication, and I've used like the con threading arrow to say, hey, if the mask is needs to be 16 bits long, apply this function. If the mask needs to be 32 bits long, apply this function instead, and then sum up all the results. And it's worked out pretty well in that sense for me.
Very nice. I'm excited to hear that. So let's see. We just lost Shiza. Okay. Hopefully she'll be back here momentarily. All right then. So that is beautiful. That is exactly why I was so enthused by discovering cond thread. So like your normal thread macro, so without the cond, it's going to pass this down. But the way to think about it is that it's passing it down the right side of all of this. So let me actually, I'm going to use Clojure align here to line these up a little. It didn't do much there, but okay. So we've got the left-hand sides, and those are the test, and then the right-hand sides are what is done to the data, just like a regular threading macro, if the test is good. So if it's not good, we skip it. So we go on down, we've got our map. we're adding things. So if we've got an ID number that was passed in as an arg, we're going to say where, the SQL. And by the way, this is one of the beautiful things about using data structures to generate our SQL, is we can do data structure stuff to our structure, and it affects the SQL that comes out. So it's much better than writing up the SQL string manipulations that you'd have to do otherwise. So okay, if we have an ID, we're going to say where that ID is the thing. Otherwise, we're going to grab all the stuff. And then always, so in this case, I chose the convention keyword next. And remember, keywords are truthy. So it's just truthy. It doesn't mean anything. It could be, in some cases, in old days before one of our developers corrected me, I used magic numbers like 1 to mean next. And I don't recommend that. But whatever's truthy can work here. So now, take that data structure and make it into an SQL string. Now, read that SQL off the database, because we have DBR up above. And then if I gave it an ID before, then I'm expecting that result to come back with exactly one result. So I don't want a list of one result in this case, although you could argue that maybe you do want a list so you're homogeneous. But in this case, I said, no, if I said I want one thing, just really give me one thing, not a container of one thing. So I grabbed the first. And then if that second arg up above, select field keys, if there's only one key I wanted on that thing, actually just give me the result of that key. So remember that in our database functions, you can say which fields you want, and it gets constructed into the query, because we use the select field keys or up here. So either we grab all of them or we grab just those things, and that's handy because rather than limiting our result using Clojure, we get to use the optimizations of the database, because this is what databases are good at. And they can be a little more, they can use some tricks that you don't need to think about in Clojure. And then let's just decode a little bit of what's going on here. So as a note here, all right. So we're still here. We've broken for the first time, we've broken our con thread into 2 lines because they're a little bit bigger. So this is the test. The test is, was there only one field you actually wanted? And if that's true, then we have a nested thing here. So we're going to find out which one did you want. We're going to grab that. We're going to say first, but we know there's only one because we just tested for that. So we grab which one you wanted. Then it's a keyword, so we get it out of the thing, out of the map. And that whole operation is a function, which we then call on our stuff so far. So that's how this decomposes. All right. So we talked about a number of things here, but we started out by talking about def method. So in this case, def method is using the check that, oh, this is a sequential thing that we got, meaning an ID number. You gave me an ID number, and I'm using that to grab out of the database these things, and I use const thread to fine-tune my result to more precisely what the asker wants or needs. Now, to get a full picture here of def method, let's look at another implementation. So if instead of an ID number, you said read a map, what do we do? All right. So first we destructure that map. So, and by the way, you'll notice again from the def multi, this was an underscore. But now because in the dispatch, we don't care about it. But now in the function itself, we do care about it. So instead of underscore, we're calling it what it is, table keyword. And then the map, because this is the map version. Okay, so we do some destructuring on that query map where we say we expect to see fields where ID and order by, and fields have a default. So if you don't give me fields, I'm going to grab every field. So in SQL, this is just the star. And we have a little more elaborate here. We have some more in the let setup here. So update where is a function which will apply in our thread. And when we apply it, we're going to check if there was a where thing then we're going to update the query to have where that. So in this case, perhaps the reason this is here is because maybe you gave me an ID, so I know you want that ID, but maybe you also want something else. So where it's got a number and it's got an ID number and it's also, or maybe it doesn't have an ID number, maybe it's nil, and it's also got some other parameter. So where the date is yesterday or whatever. So in that case, we're supplementing our where using update. So we're using update with a conj to say the where is going to be a vector because, again, we are converting data structures into the SQL so that we can use all of our updates in a/ and all of those things. And then we're going to customize that where to include both the ID and the new criteria. And then we have a similar function we set up right here for how we get just one field out of here. And then we step into our cond here, very similar to what we had before. We customize, because it's a map, so we expect it might be richer. When we were doing sequential, maybe you passed me an arg number, maybe you didn't, and that was as rich as it got. But here you may have passed me a map that could have a number of data points that are important for my query. So I'm going to customize here, select, from, and so on down the list. And then it's basically the same thing. We get one field, we query the database, all those same things. So the important thing here is that we have a def method, and they actually, as we just saw, they function a little bit differently based on whether you simply gave me an ID number or whether you gave me a map that includes ID and other things as well. And so the query, the SQL query gets customized based on either of those things. So the point here is that def method or def multi allows me to dispatch a more sophisticated criterion. So it's one thing to dispatch and say, oh, you gave me 2 args or you gave me 3 args. But it's more useful here, or more powerful, I should say, to be able to dispatch based on other things, like whether the type of thing the type of arg you gave me. So that's the gist here of the multi-methods. Any questions or statements? All right. Now, multi-methods are also a thing in Clojure script because they're part of Clojure core. However, the way JavaScript requires Clojure script to implement them means that sometimes they behave a little bit differently. So I don't have the gotchas on top of my mind right now, but we've encountered them before, where using a def method or a def multi in Clojure script sometimes causes different behavior than you expect. So just a warning there. Usually they work fine, but occasionally they do weird things. So with that super useful warning, I think we're done here. So